Tady requested that I do practice 4-7 next, so I did. Before I started, I wrote just a process to help me solve these. I wrote, first you do your fast fact, then you count your decimal places in your factors, and third, you shift your product, which is your answer. So I have 5/10 times 4/10. Okay, my fast fact, 5 times 4 is 20. I have 1 decimal place here and 1 decimal place here. That means I need 2 in my answer, so I shift my numbers 2 spots, so it gets 100 times, or it gets 2 times smaller, 2 shifts smaller. So then I have my answer of 20 hundredths. Same thing over here. 2 times 8 is 16. Count my decimal places. 1, 2, 3. So I need 3 decimal places. 4 times 5 is 20. 3 decimal places. 9 times 9 is 81. 2 decimal places in my factors. 2 need to be in my product. So on and so forth. 5 times 8 is 40. We shift. 3 times 9 is 27, and we shift. It's really important to go slow, or else you could make a silly mistake here. Looking here, your strategy here is to multiply, then look at your factors. However many decimal places are in your factors, you need to put into your product. 1.8 times 7, we get 126, but then we need to shift in 1 spot. 24 times 20, we get 480, but we really don't because we need to shift because this is 24 hundredths. So we get 4 and 8 tenths, or 4 and 80 hundredths. But the rest of these, so you multiply, you count. You'll see here I put numbers, so I wrote 2, that's for the 2 decimal places, and here I wrote 1, just so my brain knows, okay, so I have to shift 2 plus 1 3 times in my answer, or my product. Down here it says solve using mental math. So this 100th, that means it's getting 100 times smaller. So if you think about your place values, shifting 1 spot makes it 10 times smaller. So shifting 2 spots makes it 100 times smaller. So I need to shift my decimal, which if there's not a decimal written, it's always after the ones place. So I had to shift it 100 times smaller. So I had to shift it 2 spots. So 81 became 81 hundredths. 514, I had to shift it so it became 1/10 as much, or 10 times smaller. So I moved my decimal in 1. So it went from 514 to 51.4. Last I had 51 and 4/10. I'm sorry, I read it wrong. 9,037 times 100th. So it needs to get 100 times smaller, or shift twice, like we did for 15. So it becomes 90 and 37 hundredths. Down here again, you'll see I cubed my answer. Or sorry, I cubed my question. So since this whole paper was about multiplication, you could probably infer that these problems would be multiplication, but it's good to still circle, it's good to box keywords. So in order to solve number 18, you had to multiply 29 times 15. You line up your numbers, not your place values, because you fix your place value at the end. So 29 times 15, I got 435, but not really, because this is 15 hundredths. So there's 2 decimal places, so I have to make it 100 times smaller. So it becomes 4 and 35. So it becomes $4.35. Same with here. What's nice about this one is it says that is the same as multiplying 10 and 8 tenths by 100th. So it's actually like these mental math problems up here, and it gave you how to solve it. So 10 and 8 tenths times 100th, 2 shifts to the right, so it has to become 100 times smaller. So it became 108 thousandths of a meter. Last one. Each lap around the track in lane 1 is a quarter of a mile, or 25 hundredths of a mile. Delvin ran 10 laps in that lane. How many miles did he run? So it's 0.25, 25 hundredths times 10. When you multiply by 10, that's 1 place value shift to the left. So the number has to move 1 place value shift to the left. So that means that your 2 would move to this place, and your 5 would move to this place, resulting in 2 and 5/10 miles. So that's how many miles he ran. I also showed 0.25, if you think about quarters, that's 1/4 or 1/4. So you could have also solved it with an understanding of fractions. 1/4 times 10 over 1 equals 10 over 4. And then when you convert that to a mixed number, you get 2 2/4, which is equivalent to 2.5. 2.5, 2.5. And that's math. Hopefully this helps, Tatey. Thanks.